Hello, we're learning about graphing linear functions today. So the success criteria is I know I've got this when I can graph linear functions, decide whether a situation describes a linear function, and write equations in function notation. So the key vocabulary is a linear function is a function that can be written in the form of f of x equals mx plus b, where m is the slope and b is the y-intercept, in that slope-intercept form. So A, it says graph g of x, it's just the name of a function. Graph g of x equals 3x minus 1. Compare this with the graph of f of x equals 3x. Okay, so to do these, we're going to use, for right now, we're going to use a table. Okay, so we are going to plug in all these numbers for x into 3 times x. So if I do 3 times x, 3 times 0 is 0. 3 times -1 is -3. 3 times 1 is 3. Okay, now the only thing I have to do this is subtract 1 from all of these steps. So 0 minus 1, -3 minus 1, and 3 minus 1. Now we're going to plot. Okay, so we're going to plot these 2 points. So 0, 0, -1, -3, and 1, 3. Okay, now we're going to draw this with a straight line as best we can. Okay, now we're going to plot 0. I'm going to do it in a different color. 0, -1, -1, -4, and 1, 2. Actually, I'm going to use my ruler for this so I can get it straight. As possible. Whoops. There we go. Okay, now what do you notice about those? Only thing different, so we're comparing, okay? The 3x minus 1 is shifted down vertically by 1. So notice the graphs are the same, except it's shifted down 1 unit. Okay, 1b, we're going to do the same thing. So we're graphing it using a table. So I'm going to plug in 0 for this x. So -4 times 0 is 0. -4 times 1 is -4. -4 times -1 is a +4. And -4 times -2 is 8. Now we're going to subtract 5 from all these to get the -4x minus 5. So minus 5, -4 minus 5, 4 minus 5, and 8 minus 5. Okay, now we're going to plot these. So 0, 0, 1, -4, -1, +4, and -2, 8. Okay, and I'm going to get the ruler so I can graph that straight as possible. Let's see. Okay. All right, and then I'm going to draw my, I'm going to draw my line, or I'm going to try to. Okay, and then I'm going to plot the other, so 0, -5, 1, -9, -1, -1, and -2, 3. I'm sorry, this point is in the wrong spot. -1, -1. Okay, now I'm going to move this and I'm going to graph it. This ruler is not helping me a whole lot. I'm just going to try to freehand it. Okay. This is why I use a ruler. That's really bad. All right, so now we're going to compare them. What would you say? So it's the same, except for the purple line is shifted down 5. Now you can see that because like this point right here is at 0, 0, and then if you go straight down, that next point is at 0, -5. So it is shifted down 5 units. Okay. All right, so you do some of these and tell me if you have any questions. Pause it. All right, so for a line with positive slope m, as m increases, the line becomes steeper. For a line with negative slope m, as m increases, the line becomes steeper. Okay, so let's review. All lines pass through the vertical line test for functions except vertical lines. All lines are graphs of the functions except vertical lines. All linear functions can be written in the form y equals mx plus b. Horizontal lines, y equals c, can be written as f of x equals c, and our functions, vertical lines, x equals c, are not functions. All right, to find a x-intercept, you plug 0 in for y and solve for x. To find a y-intercept, you plug 0 in for x and solve for y. All right, so number 2, graph the equation by finding the x and y intercepts and then write the equation using function notation. All right, so we're going to graph first by finding the intercepts. So if I plug a 0 in for x, I will get, remember, divide by -1. So I get y equals -3. So if x equals 0, y equals -3. If I plug a 0 in for y, I get x equals 3. So we're x equals 3, y equals 0. And then I'm going to graph that between these 2 points. There we go. All right, and then write the equation using function notation. All right, so to do that, I'm going to have to put this in slope intercept. Okay, so I'm going to take it up here. So I've got x minus y equals 3. So I can subtract the x from both sides and multiply or divide everything by -1. So I get f of x equals x minus 3. All right. 2b, it says graph the equation, find the x and y intercepts, then write the equation using function notation. Okay, so we're going to do this again. So if I plug in a 0 for x, divide by 3, I get y equals 2. So that point is 0, 2. And then if I plug a 0 in for y, divide by 2, I get x equals 3. So that point is 3, 0. So I'm going to plot 0, 2 and 3, 0. And I am going to draw the line. Whoops, I missed. Between these 2 points. See how that works. There we go. It's a little better. And then, okay, now we have to put it in function notation. So I'm going to say 2x plus 3y equals 6. Okay, so I need to get it in y equals mx plus b. So subtract 2x from both sides. We get 3y equals -2x plus 6. Divide both sides by 3. So you end up getting f of x equals -2/3 x plus 6/3, which is 2. Okay, here's one for you to do. So go ahead. And that is your answer. And the graph should look like, here we go. So this would be at -8, 0 and 4, 0. So then this line would go between those points. and it would look like that. All right, example 3A. A manufacturer company needs to produce stainless steel rectangles with widths of 2 units of varying lengths. To find the area of rectangles with a width of 2 units of varying length, we multiply the length by 2, the width. So use this information to complete the table. That says A. B says graph it. C says use parts A and B to decide if it describes a linear function. And then if the answer to C is yes, then write a linear function in function notation that describes the function. All right, so let's do this. So, all right, the length is X, the width is 2, and they want us to find the area. So we know that area equals length times width, right? So if the length is 1/2 times 2 would be 1. 5 times 2 is 10. 3.5 times 2 is 7. 7 times 2 is 14. 4 times 2 is 8. So if you go on to the next slide, you will see this in that table. Okay, so it says use it to complete the table. And then B said graph it. So all you have to do is plot those points as best you can. So 1/2 and 1, 5 and 10, 3.5 and 7, 7 and 14, and 4 and 8. So from that information, does that look like a linear function? Yes, it does. So if you go back to the table, for every one it's going up, for every X, the Y doubles, okay? So it says, from the table or graph, notice that as X increases by 1, for example, Y increases steadily by 2. This situation describes a linear function. And then D, if the answer to part C is yes, write a linear function. So if we're steadily increasing by 2, that would be f of X equals 2X, because to get Y, we would multiply X by 2. All right, 3B says to find the volume of a cube Y, find its side length X. We cube X. So we're cubing, they're telling us what to do. We cube X. So use that information and then graph it and then decide if it's linear or not linear, okay? So we're gonna cube X. So 3 cubed would be 3 times 3 times 3. 1 cubed, 1 times 1 times 1. 1/2 cubed, 1/2 times 1/2 times 1/2 is 1/8. 2 cubed is 8, and 5 cubed, 5 times 5 times 5 is 125. Obviously, this graph is not going to be perfect for those numbers, but if you look at this slide, it will show you what that graph looks like, okay? So is this linear? No, of course not. It's going like this. That's not linear. So since it's not linear, we cannot do anything with D. All right, so 3C, you go ahead and do this. So pause it, and then I'll show you the answer in a second. Okay, your table should look like that. Your graph should look like it does in B. It is a linear function because you started out at 42 and you're increasing by you're increasing by 0.3 for every mile that you drive. So let's go back to the problem. It says plus 30 cents per mile. So you're starting out at 42 and you're going up 0.3 for every day. So the function in function notation would be that. Okay, I know I've got this when I can graph linear functions. You can do that with a table with X and Y intercepts or in slope intercept form. Describe whether a situation describes a linear function, and then write equations in function notation using that f of X. So do you really understand this? How would you graph the function f of X equals negative 2X plus 7? You would evaluate the function for 3 values of X and make a table to show the corresponding 3 ordered pairs that belong to them, then plot those points and draw a line through them. If you wanted to apply it in slope-intercept form, also you can go to 7 on the y-axis and then go down 2 and over 1 to the right. If you understand this, then you've got it.